Okay, hello and welcome back again. Now, in the first few sessions, we have spoken about how to define artificial intelligence. We have looked at a bit of a history of artificial intelligence, and we have also seen the importance of data in the field of AI. So, in this video, we will talk about the machine intelligence continuum in a bit more detail. But before that, we need to understand what exactly it is. So, the machine intelligence continuum was provided by Yao et al. In their 2018 book called Applied Artificial Intelligence, a Handbook for Business Leaders. Really good book if you want to get at least a grasp on artificial intelligence and how the machine learning in itself works and what exactly do these different continuums mean. So, in a very basic sense, these continuums are a medium to categorize AI or machine learning systems into different categories and based on their capabilities, right? And why is it so useful? Because it allows us to understand that where the system or where the field of AI has reached and what can different AI systems do. Because in our daily lives, we see a lot of different organizations, companies, websites, objects using artificial intelligence. But somehow we are not able to understand that what level of evolution has that system reached, right? So, for example, a chatbot, a very basic chatbot, might seem pretty fancy to many people, but in essence, it's the most basic form of artificial intelligence. In addition to that, there might be some recommendation software which are a bit more evolved compared to a chatbot. So that is why I just wanted to go through these 7 different categories, just that you understand where the field of AI is and what are the things which are still not possible in the field of AI. So to begin with, the first one, the very basic one, is a system that acts. Now, for those of you who have a basic understanding of coding or are familiar with Python, for example, would know about the commands of if, else, elif commands, right? For those of you who don't worry about it. I'll give you a very simple example. Whenever you are asked a question on a website, so generally if it's a yes no question, right? So for example, you go to a website, the website asks you, are you based in India? You can either say yes or you can either say no. It cannot have an answer which is a maybe, right? Because it's an absolute situation in which you can be or in which you cannot be. In that case, it will ask you a separate question. The answer to that would lead to another question or maybe an action on part of the website. So these are the kind of situations which we call as if, else, elif situations, but no need to go into that. Systems that act, the most basic example is your cruise control in your car, right? So these are rule-based automata which have a predefined script. Now, a cruise control can either be switched on, it can either be switched off. It cannot be in between. So any situation where there has to be an absolute answer to the situation, whether yes or no, would be categorized as a system which acts. Okay, moving on. Right, the next category is systems that predict. Now, this is one of the major categories of artificial intelligence today. And as you can see on your screen as well, the medical community is extensively using systems that predict. So, if you remember one of the previous lessons, we have spoken about how accurate machines have actually become in predicting diseases like breast cancer or tumors in the brain, hemorrhages as well, even the density of the bones, etc. And they are doing so well that general prognosis or diagnosis of a doctor is somewhere in the range of say 60 to 65% accuracy, but AI is doing it at an accuracy of say 90 to 95%. So how does it manage to do that? Well, it's analyzing the previous data which is provided to the machine, and by using certain algorithms, it produces probabilistic predictions. Why is it called probabilistic? Because you can never be 100% sure of the outcome. So even an AI system, even if we provide it with say hundreds of thousands or millions of data points, it's not possible to provide 100% accuracy, at least in today's date. So these are the kind of systems which predict. So whenever a machine is taught to predict something based on prior information, either in the form of supervised learning or in the form of unsupervised learning or either in the form of say reinforcement learning, but whenever you are expecting the machine to predict a result, that is something known as system that predicts. I've already given you a couple of examples. If you need more or if you know of some examples, you're free to put it in the comment section below. Otherwise, you can always write to me and I'll be happy to provide you with a few more examples. Okay? Right. Moving on, the third category is systems that learn. Now, as the name suggests, these can learn to perform tasks without being explicitly programmed. And if you have already guessed it, these are machines mostly under unsupervised learning. So we use different techniques like k-means, clustering methods, etc. when we want to train a machine without providing it explicit labels to do something. But you always need to remember, and that is why we had an entirely separate video on this topic, is that data is pivotal for this. Okay, if the data is not clean enough, if the clusters are not well defined, if you don't know what categories do you want the machine to formulate, in that case it's very difficult for the machine to actually come up with results. Now now, as you can see on my screen, I've given you an example of robotics in the factory, and most of these robots, whenever they're programmed, they are actually self-correcting. So if they know that this is the task which they're performing and it is not the way it should be performed, how do they know? How do they know that? Either by in providing incentives or providing punishment. So this is a form of reinforcement learning. So both these methods of unsupervised learning and reinforcement learning typically lead to a system which is able to learn. Okay, so moving on, we have the fourth category of systems, which are systems that create. Now at this point, I want to ask you a question, that can machines actually create something? I mean, the understanding which we had about machines is that we can teach them to do something. Yes, they might be able to predict a few things, they might be able to generate some hypotheses, they might be able to carry out some actions based on the data which we have provided. But are they actually able to create something extraordinary? Turns out the answer is yes. So for example, the Flow Machines project of Sony actually used artificial intelligence, and they generated their own song based on Beatles. Now, if that's not extraordinary, I don't know what is. So the machine was actually able to listen to the songs made by Beatle, and it was actually able to create a song, and it was actually titled Daddy's Car. So it's not science fiction, but it actually happened in reality. Similarly, Google actually hosted, sorry about that. So what I was telling you is Google actually hosted an exhibition of artificial intelligence drawings. So these were drawings which were actually created by artificial intelligence, and one of them is on your screen right now, which actually, so not just this drawing, but the overall money which was raised in this exhibition was close to $100,000. So if before today, if you had a doubt about an artificial intelligence machine's creativity, you shouldn't have it any longer, because they have been able to create things for a really long time. Both these examples I've given you are more than 2 decades old. So you can imagine that the field is really growing when it comes to systems that are able to create new things. Right. The sixth category is the systems that relate. I'm still not entirely sure why I have this sad looking person on the screen right now. I'm sure I put it in with some intention before, but now I've completely forgotten. So this is something which is all about emotional quotient versus intelligence quotient. And the question which I want to ask you, for those of you who actually use Apple products, for example, would you consider Siri to be an emotional AI? I'll let you answer that in the comment section if you want, but if you think the answer is yes, I would really like to know how. If the answer is no, that would make more sense right now, because Siri as an assistant at this point of time is not really able to read emotions. So the machine's capability to actually understand emotions is not entirely a fiction. It actually happens, and this is a field in AI known as sentiment analysis. So using opinion mining or emotion AI, what the machine is able to do is extracts and quantifies emotional states from humans through different media, right? How does it work? Basically, you show a machine different data points, for example, angry people. So you provide all that audio information to the machine, say 10,000 different samples where people are angry, 10,000 different samples where people are sad, are happy, and so on. And yes, now I remember why I have this photo here. So can you see this red dotted line or this red laser line going through this person? So this is actually something which is used for facial recognition or facial expression as part of sentiment analysis. And for those of you who are not aware how facial recognition actually works, let me give you a very brief 30-second crash course on it. So some of the dimensions of a human face never change. Okay, so the distance between your eyelids and the distance between your chin and your forehead is something which doesn't change throughout your lifetime, and that is why the machines use this to actually read your data, your face, and that's how they are able to analyze who the person is. So when it comes to facial expressions, once again, data is fed to the machine in hundreds of thousands, not if not millions of data points, where a person looks sad, where a person looks happy, angry, and so on. And by collating all this data, the machine is finally able to understand how a person is feeling, right? So you need to understand this, that the machine is not actually feeling this. So this is something which humans are capable of. We can understand feelings of others, but the machine is not feeling it, but it's actually understanding the feelings of a person, right? So just by providing that data to a machine, we can help it analyze the expressions or the mood of a person. Now, obviously, if this person says that I am actually happy, but even we were not able to read it, let alone the machine, then it's very difficult for the machine to understand it, right? So it's based on the conventional methods which are used to understand emotions of a person and are fed to the machine in order for it to understand what emotion it's reading. And an example of this is this software called Affectiva. So what exactly does it do? It helps advertisers improve the effectiveness of brand content by analyzing consumer reactions. How does it do that? It's a really interesting project, and I would request if you can go and look at it online as well. Okay, the next category, I think I called the previous one sixth, but that was the fifth one, and now we're on the sixth one, which is systems that master. The perfect example of systems that master are humans, right? So you can see a flamboyant tiger on your screen right now. And the question which I want to ask you is that how many times does a toddler or a small kid or an infant actually needs to see a tiger before recognizing one? Maybe 5 times, maybe 10 times, maybe 20 times, right? But after that, the kid will be able to recognize that this is a tiger. But is it the same with AI? Not exactly. An AI system might have to be shown the images of a tiger at least 100,000 times. And even then, if you change the angle or if you show, say, a pillowcase with the same photograph on it, it might still recognize it as a tiger. And that is why humans are so different from machines, because we have this ability to construct abstract concepts and strategic plans from sparse data. In simpler words, we are able to make sense out of things which might not make sense to a machine. And this is where the limitations of AI begin. Okay, so when we go to the previous screen here, the systems that relate, we still have made some progress in terms of sentiment analysis. But when it actually comes to systems that master, that is the stage which we still have not reached when it comes to artificial intelligence. And the reason for that is because creating meaning out of abstraction is really difficult, and even a lot of humans are not able to do that, and that is why we are not able to configure that into the machines. Okay, so the seventh category is even more interesting, and we have Mr. Ultron back to our classes. Now, I am sure you have guessed by now that I'm a huge Avengers fan, and somehow people don't understand that many of these movies actually provide you some very interesting concepts which might become reality in artificial intelligence one day, if not today. So systems that evolve are basically the ones which can exhibit superhuman intelligence and capabilities. As humans also, our intelligence is limited in a lifetime. So if you know about Albert Einstein had an IQ of 161. Now you might have some people which have the above IQ, above the 161 value, but generally most of us fall below that. So this limitation of the human brain is something which we are aware of, and generally we say that we don't use even a fraction of the brain's capability, right? So this is something which is known as a wetware. This concept where our intelligence is limited to an extent is known as wetware. What AI scientists uh, kind of want to do further is that they want to expand this limitation of wetware, at least in machines, right? So the stage where actually machine intelligence surpasses human intelligence, so this will be a stage which is known as technological singularity. This is exactly which most of the movies have focused on, right from Matrix to Avengers, where the machine actually makes sense out of things. Even X-Men does it to a large extent. In one of the movies. Sorry, I forgot which one. But the concept is that the machine evolves to such a large extent that it's able to reason better than a human, it's able to think better than a human, and that is the stage where the system would have evolved beyond technological singularity. But at this point in time, we have still not reached this stage. We have not even reached the stage where systems are able to master themselves. But the whole objective of this video was to make you understand what are the 7 or 6 different categories of machine intelligence continuum. Why do I say 6 and 7? Because you will find certain variations when it comes to different text, and I wanted to give you the extended version, which is the 7 different categories. What it will allow you to do is, as I told in the beginning of the video, it allows you to categorize AI systems and understand that where the research has actually reached. So that is all for this video. Thank you for being so patient, and I'll see you in the next one. Thank you.